show you, actually it's very simple. Right, this is what it looks like in the end. Okay, I started with a font node. Okay, choose my font, type in the words, then I use a divide node to chop it up, and then this facet is just to break it up, break it apart. And if I break it apart, this is how it looks like. Right. Okay, then I assemble it to make it into different pieces, and then I send it into a dynamics network with some forces. Okay, when I play back, it will split apart. Okay, then after the calculation, I bring it back with the import, unpack it to take care of the colors, add color to it. Then each one of them is extruded to give the thickness. Okay, so I'll start a new session. Okay, so if you're ready, the first thing you do is to drop down a font node. Okay, so you have a font, so this is my logo. Okay, got it? So the font node is quite useful. You can actually choose all the available fonts on the computer, right? So whatever is available for your Premiere Pro is also available for your use inside. Okay, Wingdings I think doesn't work. Okay, let's stick to something that's simple, Helvetica. So type in the fonts that you want and also the words that you want. Let's say I use what I did earlier on. Okay, something like this. Okay, this Algerian font. Then what I did was I want to chop it up into pieces, so I use a divide node. Now, if you look at divide in its default settings, basically it just makes your object more complicated, right? With more triangulation of polygons. So what we want is actually not the default setting. So you need to turn off convex polygons. Okay, turn off convex polygon. Turn this off. And then turn on instead Bricker polygons. So Bricker will allow you to make polygons that are squarish. So if you reduce the size to, let's say, 0.07, okay, something like this. Okay, try to get about 400 to 500 primitives. Okay, no more than that, so that it will be faster for you to calculate. Okay. Yeah, I think I don't like this font. Pick something simpler. Okay, this one. Okay, now after you chop it up, you still, basically all the polygons are connected together, so we need to break them apart. So you use facet. Okay, facet. And then how we chop them up is to turn on unique points. Okay, turn on unique points. Then to check that it's been broken up, you can show the effect with the exploded view. Okay, exploded view will actually, if the polygons are separated, you can actually use the scale to break it apart. So maybe for some of you, you would just want to have this. You can always, one idea is you can start this as your last frame, and you can scale down, and then you scale down to 1. Sorry, scale down to 0, and then you will have your logo. Right? You can think of animating this as well. Okay. So the key thing is the facet is to break the polygons up. Break the polygons up. Okay. Is it working for you? Okay, so the exploded view is just for checking. Okay. It's just to check whether it's being broken up. Right, so we will disconnect it for the moment. And then we name this, okay, maybe out words or what out pieces. Okay. Now in order for us to move it with forces to break it apart and to create something more interesting for it to flip around, right? We need to use dynamics, which you haven't done. So it's like, dynamics is like a physics calculator inside Houdini that allows you to apply forces to geometry so that you can move it around, you can make it fall with gravity, you can make it move faster or make it explode. Okay, so that's what we're going to do. So to do that, we need to drop down a dot network. Okay. So we are going to send our pieces into a network, a special network to do the calculations for the forces. So key in dot network. Okay, it doesn't need to be connected. Basically, it's another world on its own. So if you double click on .NET, okay, you are inside another region of Houdini. You're in dynamics, in the dynamics world. Okay. Can? Okay, but I forgot to do something. Now, before I can send the pieces into the dot network, I need to prepare it in a certain way so that it can be easily calculated in Houdini. So I I forgot this step called assemble. Now this assemble will give names to each and every single piece. And more importantly, you will create this pack geometry. So I need you to put down an assemble node after the facet and then turn on create pack geometry. This one, very important. Okay, I think you have seen pack geometry in copy. I taught you a little bit about it. Basically, the pack geometry allows the calculation to be faster. Okay. Right, then now we can go into dot network. Okay, so we are going to use a RBD packed object. RBD packed object. Inside the dot network, call a RBD packed object. Okay. So the RBD packed object is actually the pieces. So we need to point it to the RBD packed object. So in the sort path, you need to look for it. So I've named it conveniently. I call it out pieces, right? And I spell it in capital so it appears at the very top. Okay, so what you do is for the sort path in your RBD packed object, right? Click on this operator chooser and then select out pieces and hit accept. So you will fill it up, and then when you display it, you will see your object brought into the dot network. Remember, the dot network is another world, right? So in order to calculate this RBD pack object, you need to have a calculator or a solver. So you need a rigid body solver. So you just tap rigid, right? Rigid body solver. You'll see a, sorry, the icon is a fish. I don't know why. Is it a fish or a bouncing ball? Yeah, bouncing fish. Okay, so the rigid body solver is, right, I just put down the notes to calculate dynamics for RBD object. A very long note. Huh? So this is your object, right? This is the from out pieces. Okay, and then this is to calculate. So right now, if you press play, nothing happens because actually something is happening. You can see it's breaking up. Okay, because it's actually subject to the certain kind of forces, okay, which we haven't actually applied. So for example, if you drop down gravity force, okay, if you just drop down gravity force and press play, your object will drop down. So if you want it to rise up, instead of using a negative gravity force, you can use a positive gravity force. Let's say 0.1 in the Y. So this is X, Y, and Z. Then your object will rise. Okay. Now, so what I wanted to do is to put in a wind force. Okay. After the RBD solver, put in a wind force. At the moment, the scale of the force is very high. So you see a wind force of 100, the default setting is 100. You press play, your whole object disappears in no time. shun, right? So this is the direction of the force is 0, 0, 1, so it's X, Y, Z. So right now, I turn off my... Okay, so you see here, because the scale of the force is 100 and it's in the Z direction, right? So the wind is blowing it away in the Z. So we actually don't want this wind force in this sense, but I want to use a noise. So I put this to very, very low, 0.001. And I actually want to use this, make use of this noise. So this noise kind of force will create something more interesting. So let's try a turbulence of 3 or maybe a frequency of 0.5 or 0.6 and an amplitude of 5. Okay, let's play. Okay, you can see that the words are actually breaking up in a noisy kind of pattern. So if you increase the amplitude, okay, you have a more reactive feel to it. Okay, the bigger the force, the greater the effect. Okay, so you need to think about your animation. If let's say you want the animation to start from frame 96. Okay, remember what we want to do is to have it, maybe you have a camera like this, right? And then after you render, you reverse the animation, you reverse the playback. And then as you reverse the playback, you are zooming out, zooming out, zooming out. And then it finally forms your work. Okay, so that's the idea. So I'm just using the dot network to create this kind of effect of blowing up. Okay. Okay, so for example, I'm happy with this, right? From 100 frames, right? 100 frames is about 4 seconds plus. Okay. So I will probably later on I will have a camera like this, and then it forms up to be this. Okay, so that is all we're going to do. So we have a RBD pet object, we have a solver, we have a wind force with some noisy forces affecting it. Okay, and we have a gravity that slightly pushes it upwards. Okay, so you play with that depending on how you want it to look like. Okay, so now we have the font, we have divided it, assembled it, and send it to the dot network. So now we need to import it back. Okay, so use a dot import. So this is to import back from .NET. Okay, so this is a special node just to import any object which is calculated inside a .NET. So we need to tell this node where to get it from. So the dot network, you need to fill it up with .NET. Okay, you need to tell, okay, this is the .NET that I want to import it back from, because in a file you can have several different dot networks. Okay, so click on this guy here, okay, and look for .NET, okay, because that's the name of the network. Then the object, okay, the object is RBD pack object something, right? So you don't need to spell it in full. So you just put RBD, it should work. Okay, because what we are looking for is anything that starts with the letter RBD. So this is the object we have created, and we are trying to import this back into the geometry, all the calculations that's done for this object. So we just type RBD star. So you don't have to spell the whole thing, RBD pack object, blah, blah, blah. You put a star, means anything that begins with RBD pack will be recognized. Okay. And then one last thing is, instead of transform input geometry, fetch pack geometry. Okay, select that. Okay, this one. Fetch pack geometry from .network. So you need to fill in, okay, 3 things. Okay, the first thing is which .network. Second thing is what's the object name, and then change this import style to this. Okay, then if you play back, you should see the calculations done earlier on. Okay. Now you notice on the timeline, you can see a blue line forming, right? So this blue line represents the fact that it has finished, okay, calculating dynamics. Okay. So you notice that the very first time that you do the calculations, it takes a long time. But after it has finished calculating the whole of the 100 frames, it plays back very fast. Okay. So if you want to see how it moves in real time, you have to switch on this clock, the real-time clock. So you will be able to judge whether this is the timing you want or not. So this is playing at 24 frames a second. Okay, if you turn it off, you will play as fast as it can. Okay. Okay, from now that we have reported it, I just want to color it a little bit different. Maybe we can color it randomly. Okay, and then I want to extrude it. Poly extrude. Okay, so you notice that the poly extrude is not working, right? Because there's one step I forgot to do. Because it's a pack object, you need to unpack it. So unpack after the import. Okay, just do an unpack. Color it by primitive random. Okay, you can choose the kind of colors you want. Okay, this gives me an idea also. I can animate this, for example, and I can create it, make my logo bling bling, or change colors like this. Okay, so for example, you can do this $T. Notice, right? So you can create changing colors by applying a changing seed. Okay, then the poly extrude. Okay, so the poly extrude, you have used it before. You're just extruding like this. Okay, but if you turn behind, it is it's got holes, right? So to patch up the holes, you need to turn on output back. Okay, output back. This must be on, so that when you extrude forward, you have the back part closed up. Okay, and then the reason for this dark regions is because of the normals. So let's fix the normals by putting a normal node, and it will help to solve the issue of the normals. Okay, just to take it a step further before I finish it off. Okay, you can because the poly extrude right now is applied to every single is applied uniformly across every single piece, right? So let's say I want this piece to have a different depth of poly extrude. Okay, let's say I want to randomize the extrusion. Okay, so what I can do is I can make use of this particular attribute. Let me see if I can find it. Okay, under local control, okay, I want you to turn on, under local control, turn on this distance scale called Z scale. Okay. So go to poly extrude, then go to your local control, turn on distance scale, and leave the name as it is. So what we'll do is, now we will control the extrusion with this attribute called Z scale. So we create attribute, create a Z scale. So this is after the color. Okay, attributes get Z scale. So let's call this Z scale. Oh, sorry, it's the value. Okay, so you see, what I did was, after the color node, I created an attribute called Z scale. And then, because I turned on poly extrude with this local control Z scale, so now if I change the value of the Z scale, okay, I can change the amount of extrusion. So let's say I want something which is random. So let's say fit 01. And random $PR. PR means primitive. So each one of the polygon has a special primitive number. So let's say I want it to be extruded from, let's say, 0.1 to 0.2 to 1.5. Okay, maybe not so nice. Yeah, PR means primitive. Okay, let me show you. Okay, let's say 0.2 to 0.8. Okay, so I have different depth of extrusion for each primitive. So what is this PR? Somebody asked. So $PR stands for primitive number. Okay, so if I turn on my attribute Z scale, okay, and I turn on this primitive number display, okay, here. Okay, at the center line, you have this display primitive numbers. Okay, turn that on. So each one of these polygons or primitive has its own number. So for each and every one of them, I generate a random number from 0 to 1. And depending on what is written from the random number, I scale it, I extrude it by 0.2 or 0.8. Okay, between 0.2 to 0.8. Okay, so for example, this polygon is 155, right? So imagine for each one of these, it's calculating. So for that, this particular polygon is 155. So you will calculate random bracket 155 for this guy. Okay. And then for this guy 104. So here you will calculate random 104. And maybe this will give 0.3 or something like that. This one will give 0.7. So each one of them will be different. Then depending on what's written, I will choose a number between 0.2 and 0.8. Okay, so for the moment, if I fix it at random 155, then everybody will be scaled. So all the polygons will be extruded with the same number, which happens to be how much? 0.567735. Okay, so but because I put $PR, everyone will have its own personal extrusion distance. Okay. Okay, so now when you animate it, this is what you get. So you have boxes flying. Okay, then from this point onwards is a matter of doing the lighting. For example, I use a skylight. Okay, so if I zoom in like this and render, let's see the result. Yeah, let me save this. I think it's crashing. Okay, so this is the render. Okay. So one last step before I come and see the problems that you have. Now, in order for you to render out, I haven't taught you this in class, right? So to render a sequence, you need to go to the out context. Okay. Change this, right? Instead of your object, go to your out. Okay, drop down mantra. Okay, this is like the render node. So it's a very complicated render node, but it's in different sections. So the main thing is you need to have a camera. So let's set up a camera first. So remember how to create a camera. Go to the view that you want, and then hit Control, click on camera. So you create a camera. So it's camera 1 now. Okay. Then you return to your out context, your mantra node. You see that the camera that is going to render is camera 1. And then you can render current frame, or you can render a frame range. So let's say we render frame 1 to frame 50. Oh, it doesn't allow you to change, so you need to delete the channels. Okay, right click, delete channels, and then change this to frame 50 or whatever. Okay, so this means render a frame range from start of 1, okay, until frame 50. And then here is, this one is a step. Do you want to render every frame? If you leave it at 1 if you want to render every frame. If you want to render frame 1 and then skip to frame 3, then you put 2. Okay, if you want to render every 10 frames, you can hit this. Okay, so I leave it at frame 1, and then you can render to mplay. Mplay is, okay, let's render to mplay. So what happens is, it will, when it starts to render, it will show you this dialog, and then once it has some form of render, you will open up this app called mplay. Okay, and you show you the render. Okay, so it's rendering frame 1, now it's gone to frame 2, and then you slowly render until frame 50, and then you can play your render. Okay, so after you finish this, you can save it out, bring it to Premiere Pro, and you can reverse it. Okay, let me stop the recording because that's all I really wanted to show you.